joins. So what is join? What for join is? So join is an operation. Okay. Simply what is join means? Join is an operation. So like you learn some various operations on database. So what are the operations, like whatever you did, there are operations on creating the table, storing the data, updating the data, deleting the data, displaying the data, while displaying, filtering the data, sorting the data, eliminating the duplicates, grouping the data. So there are operations on what? Database. So database tables. So join is also one of the operation, like grouping, sorting, filtering. Join is also one of the operation. And what for this operation is performed? This operation is performed to display the data from 2 or more tables. This operation is performed to display the data from what? 2 or more tables. You want to display the data from single table, join is not required. But you want to display the data from more than one table, 2 tables, 3 tables, 4 tables, then join is required. Okay. To display the data from one table, join is not required, but to display the data from multiple tables, join is required. So it's an operation performed to fetch data from 2 or more tables. Okay. Then now, so like definition is, join is an operation performed to display data from 2 or more tables. So for example, to display data from 2 tables, we need to join those tables. Display data from 2 tables, we need to join those tables. Okay. So in database, data stored in what? Data stored in single table or data stored in multiple tables. In databases, whatever the data, you take bank data stored in multiple tables. Anything you take, the data is not stored in single table, data stored in what? Multiple tables. So data stored in multiple tables. Okay, so to combine or to gather data stored in multiple tables, we need to join those tables. Data stored in multiple tables. So to combine or to gather data stored in multiple tables, we need to join those tables. Okay, then. So to explain the need of join operation, okay, to explain the need, I'll take one example. What is the need for join operation? So, like for example, you take Amazon. Amazon stores what? Customer orders. Customers go to Amazon. Customer place order to buy product. So that orders are stored in one table: order ID, order date, next one delivery date, next one customer ID. Listen first. order ID, order date, delivery date, customer ID. But okay, I'm just taking only four fields. Order ID is 1000. This is ordered on so and so to so and so date, like 10th of this January month. This is delivered on 20th. Customer ID is what? 10. And this is 1001. This is placed by different customer. So this is 25th. This is placed by customer 11. 1002. This is 18th of this month. Next month 27th. Customer 12. Like, okay. So this is the orders table. Order ID, order date, delivery date, customer ID. Okay. Then, so there is another table. So the table is what? Customers table. This customer table stores what? Customers data. This customer table stores customers data. Customer ID, customer what? Name, customer address. Okay. ID, name, address. So customer ID is 10. Name is some name, some address, HYD. Customer 11, his name is B, his address is HYD, but different places in HYD. Customer 12, name is C, address is HYD. Okay, then there are two. So this is the customers table. Okay, then now there are two tables. One table is storing orders data. One table is storing customers data. And finally, order should be delivered to customer. Finally, what? Order should be delivered to customer. You have to deliver the order to the customer. You give these two tables to delivery boy. Giving the two tables means giving the printouts. Take orders table 1 printout, customer table 1 printout. Give these printouts to delivery boy. Ask him to deliver the order to the customer. Can you deliver the order to the customer? Huh? You give these two tables, two printouts to the delivery boy. Ask him to deliver. Now, can you deliver the order to the customer? No, it's difficult. Why? Because this order should be delivered to customer 10. This order should be delivered to customer 10. If you know customer ID, can you deliver the order to the customer? If you know the customer ID, can you deliver the order to the customer? No. What you need? Customer name and address. To deliver the order, what you need? Customer name and address. But where the customer name and address is there? Customers table. Okay. I want to deliver this order to customer 10, but to deliver the order, I need name and address. So that name and address is there in customer table. Then what delivery boy has to do? He has to take this ID, go to customer table, find out the customer 10 name and address, deliver the order. But in this example, I taken only 3 customers. Easily can find out particular customer name and address. But assume customer table contains lakhs of customers data. In lakhs of customers data, can you manually find out particular customer name and address? No, time taking. Okay, now if customer table contains thousands of customers, lakhs of customers, so manually finding the particular customer name and address is what? Time taking. Difficult. So that is the problem here. Okay, now then because so I want to give the order details with customer details to the delivery boy. If you give order details with customer details, then easily can deliver. Okay, but order details are there in one table, customer details are there in one table. But you cannot ask delivery boy to you find out the customer details and deliver the means. It is difficult for delivery boy. Then instead of giving like this, I generate one output. Instead of giving these two tables to the delivery boy, I generate an output like this. What is the output? Order ID, what? Order date, delivery date, customer name, customer what's her address, ID is 1000, order date is 10, delivery date is what 20th, customer name is what A, his address is what HYD. If we give the data like this, now easily can deliver the order. Yes. So this order should be delivered to customer A, his address is this. Easily can deliver the order to the customer. Yes or no? Now he doesn't need to go to customer table. He doesn't need to manually find out the particular customer name and address, because we are giving order details with customer details. Okay, then. So if you give this report to the delivery boy, now easily can deliver the order to the customer. But in this example, these three fields belongs to orders table. These two fields belongs to customer table. That means the data belongs to two tables. The data belongs to two tables. Then you have to get the data from two tables. But to get the data from two tables, what we need to do is we need to join those two tables. So this is the requirement of join operation. What is the need for join? So this is the best example to understand what is the need for join operation. Okay. Then understood. So in this output, some of the fields belongs to what orders table, some fields belongs to customer table. So combining the fields of two tables and give the report to the delivery boy. That's all. This is the example. Okay. Now, oh, no. Primary key concept is different. Join is different. Composite primary key, that's what I'm saying. Composite primary key purpose is different. Join is different. So join purpose is combining the data stored in two tables. Composite primary key to uniquely identify. So their purpose is different. Now, so I want data from two tables. To get data from two tables, you have to join the two tables. Okay, then now. So this is the need for join. Now, and what are the different types of joins? What are the different types of joins? So one is what? Inner join. Otherwise it is called equi join. Next one, outer join. Outer join is three types: left join, right join, full join. Third one, non-equi join. Fourth one, self join. Fifth one, Cartesian join or cross join. Cross join is also called Cartesian join. So the different types of joins. Okay. So total how many types are there? How many types are there? 5 types. But what the most important is, okay, real time, maximum these two, inner and outer. Mostly you come across these two. Maybe sometimes you come across what? Self, but non-equi, cross join, no. So these two are most important. Sometimes you come across self join. Okay, then. So, but all are what? Joins only. All are used to get the data from two or more tables. But different scenarios, different conditions, we use different joins. So when we use inner join, when we use outer, when we use self, that you must know. Then, so first one, we'll start with what? Inner join or equi join. Inner join or equi join. Okay, inner join or equi join. Then, so when we perform inner join, okay, when we perform inner join, so inner join is performed. Inner join is performed. To perform inner join between the two tables, there must be a common field. Or the condition to perform inner join is to perform inner join between the two tables, there must be a common field. Common field must be there. If common field is there, inner join is possible. If common field is not there, inner join is not possible. So can you perform inner join between these two tables? Yes. Common field is there. Yes. What is the common field? Customer ID. Okay. But in this, suppose this is cust ID. Then no, inner join is possible. Inner join is possible. Inner join is possible or not possible? Common field is there. Okay. Now inner join is possible. Common field is there. Yes. What is the common field? Customer ID. Customer ID. Sir, common means it's not based on name. It's based on data. What data stored here? Customer IDs. What data stored here? Customer IDs. So this is common. Don't consider name. Consider what? Data. Okay. Then customer ID. Understood? So between the two tables, there must be a common field, but name of the common field need not to be same. And primary key, foreign key relationship is also not compulsory. If it is there, okay, good. If it is not there also, join is possible. Primary key, foreign key relationship is not compulsory for join. Okay, na? Then usually it exists, but if it is there or not there, still it is possible. What is requirement is common field must be there. That's all. And what must be same is common field data type must be same. Common field what? Data type must be same. If this is integer, this must be integer type. If this is varchar, this must be varchar. If this is date, this must be date. So the common field data type must be same. If data type is different, so that is not possible. Understood? Then. So what is the definition of inner join? So like inner join is performed between the tables sharing what? Sharing common field. Inner join is performed between the tables sharing what? Common field. And name of the common field what? Need not to be same. Name of the common field need not to be same. And primary key, foreign key relationship is not compulsory. Primary key, foreign key relationship is not compulsory between the two tables. Between the tables. Okay. And common field data type must be same. Okay, then. Oh, sorry. And now what is the syntax for writing the query? Select what? Columns from table names. Select columns from table names. Next one, where I'm not saying table name. I'm saying what? Table names. Where what? Join condition. So select columns from table names where join condition. Okay. Select columns from table names where join condition. So in writing join queries, what is the most important is join condition is most important. So if you can able to identify join condition, you can able to write join query easily. Okay, na? What is most important is join condition is most important. So if you can able to identify join condition, you can able to write the query easily. So this is most important. Then, but what is the join condition? What is the join condition? I want to join these two tables. I want to join these two tables. Okay, but how SQL Server knows? So joining the two tables means what? Joining the two tables means joining the records of two tables. This is the record belongs to orders. This is the record belongs to customer. This is the order record. This is the customer record. You are combining the records of two tables. Yes or no? So joining the two tables means what? Joining the records. So this the record belongs to orders. This the record belongs to customer. You join these two records, and this after joining these two records becomes one record. So that is called join means. Okay, but question is which order should be joined with which customer? This order. This order should be joined with this customer, this customer, this customer. How SQL Server knows? This order should be joined with this customer, this one. Okay, na? I want customer 10 name and address. Then how to get the customer name and address? So join this customer 10 with this customer 10. After joining these two rows, you'll get the customer name and what's it? Address. You'll get the customer name and address. Customer 10 name and address. Customer 11 is there. I want customer 11 name and address. So join this record with this record. We'll get the customer 11 name and address. Customer 12. I want customer 12 name and address. Join this record with this record so that you'll get the customer 12 name and address. Now tell me what is the join condition? To get the required output. That's all. Here, these are the two tables. This is the output. To get the required output, you have to find out the join condition. If you can able to find the join condition, you can able to write the query easily. To get this required output, what is the join condition? Customer IDs are what? Equal. If customer IDs are equal, then join. So this 10 is equal to 10, join. This 11 is equal to 11, join. This 12 is equal to 12, join. So if customer IDs are equal, then join. So that you'll get the customer name and address. Understood? Now, what is the join condition? Okay, what is the join condition? What is the join condition is like based on the given join condition, SQL Server joins the records of two tables. You give the join condition, according to that condition, it joins the records. Okay, then. So what is the syntax of join condition is what? Table 1 dot what's that? Common field equals to table 2 dot what? Common field. So this is the syntax of join condition. Table 1 dot common field equal to table 2 dot common field. So why this join is called equi-join? Because here join condition is based on what? Equal to operator. So the join is called equi-join because here join condition is based on what? Equal to operator. So the join is called equi-join because here join condition is based on equal to operator. Okay, now let's take one example. Okay, then let's take the example. I can write the query for this. But I have to create the tables. Okay, na? Then instead of this, I'll take because EMP table is already there. So I'm taking EMP table example, EMP NO, e-name, salary, department number. So 1A, salary is 3,000, department number is 10. Employee 2, name is what? B, salary is 4,000, department number is 20. And employee 3, name is C, salary is what? Like 2,000, department is 30. And employee 4, name is D, salary is 3,000, department number is 10. Employee 5, name is E, salary is what? Okay, 2000 department is null. This is the employee table. There is one more table. The table is what? Department table. Department number, department name, location. Department number is 10. Department name is accounts, some location. 20. Department name is what? Research, some location. Department is 30. Some department sales, some location. And employee 40. Next one, operations, like this. So there are two tables. One table is employee table. One table is departments table. Okay, then. Okay, now. So there are two tables. One table is employee table. One table is what? Department table. So there are two tables. What I want to display is, I want to display e-name and what? D-name. Okay, I want to display e-name and D-name. Employee name, department name. Okay, I want to display e-name and D-name. Employee name, department name. Then what? But here, what is there in this table? Department number is there, but user is asking what? Department name. So user is asking the department name. How to get the department name? Okay, now how to get the department name? So then to get the department name, join this record with this record. You'll get the department name. Employee A department name. To get the employee department name, join this record with this record. Then, so I want to get this employee department name. Join this record with this record. You'll get the department name. So your department numbers are equal, then join. So that you'll get the department name. Yes or no? Department numbers are equal, join, so that you'll get the department name. Then how to write the query? Select what? E-name, D-name from EMP, comma, DEPT, where what? Select E-name, comma, D-name from EMP, comma, DEPT, where what? EMP dot department number equals to department dot department number. EMP dot department number equals to DEPT dot department number. Okay, then. Okay, then. So if department numbers are equal, we are joining so that you'll get the department name. Okay, then. So, but how it works? Okay, then how this works? Let's take this. It go to the first record. It go to what? First record. What this is? EMP dot department number. What this is? 10. So this left side value compared with each and every value of the right side. Left side value is compared with each and every value of the right side. 10 compared with 10. Matching up? Matching. Once match found, so this record is joined with this record. That means these two rows becomes one row. These two rows becomes what? One row. From that row, what you are selecting? E name and D name. What is E name? A. What is the D name? Accounts. So then it will show like this. A accounts. A accounts. Next, so then 10 compared with 10 equal join. But this 10 is compared with other departments or not? This 10 compared with other departments? Compared or not compared? Compared or not compared? So will it stop here only? Or will it go to the next departments? See, listen. In department table, department number is primary key. In department table, department number is primary key. 10 compared with 10, match found. Once match found, it will not go to the next record. Because how many values exist with the matching to 10? Only one. Because primary key doesn't allow duplicates. So once 10 is matching to this 10, match found, join, but it will not go to the next record. That's all. It will go to the second row. First row is completed. It will not compare with other departments. Understood? Then, if it is not primary key, 10 compared with 10, matching, join. Next, it will compare with other departments also. 10 compared with what? 20. 10 compared with what? 30. 10 compared with what? 40. Because it's not primary key means duplicates may exist. Yes or no? Then that's all. So that is the difference between declaring primary key, not declaring primary. If you declare primary key, then that gives good performance. Okay, na? If you don't declare primary key, then so performance gets affected because it has to compare with what? This is compared with what? All. This is compared with what? All. This is compared with what? All. But if once it is primary key, if it is a primary key, 10 compared with 10 match found, then it is not compared with what? Other departments. Now, next it go to what? First one is completed. Go to second one, 20. 20 compared with what? 10, not matching. 20 compared with what? 20, match found. Once match found. So this is joined to this one. So these two rows becomes one row. What we are selecting? Name. What is the name? B. Name is B. What is the, like what? Research. Next one. It go to the next record. This one, next record, 30. 30 compared with what? 10, not equal. 20, not equal. 30, equal. So this is joined to this one. Okay. This is joined to this one. Then so see what's that? Sales. Next one. It go to next one, 10. 10 compared with 10. Equal or not? Equal. Then what about this? Null. So null is not equal to any. So this is selected or not selected? Not selected. That's all. This is the output you'll get. So 10 compared with 10 matching, 20 compared with 20 matching, 30 compared with 30 matching, 10 compared with 10 matching. Null is not matching. Okay, now then. So I want to test this. Okay, I want to test it. To test it, first what? Create the tables. First check tables are there or not. Select sort from EMP. Next, select sort from DEPT. Select sort from DEPT. So employee Smith is working for 20. Smith is working for 20. So 20 is matching to this 20. What the department name is research. Alan is working for 30. 30 is matching to 30. What the department name sales. Now let me run the query. So employee data stored in EMP table. Department details are there in department table. You want to display employee details with department details. Then what you have to do is join. So Smith is working for 20. 20th is research. Alan is working for 30. 30th department name is sales. So what it is showing? Employee name and what department name. Okay, now then. So E name and D name. Clear? Now. So, but in this, like I want to show E name, department number also. I want to show the department number also. Then I want to show E name, department number also. Then select what? E name. Next one. Department number, D name from EMP DEPT, where EMP dot department number equals to DEPT dot department number. Okay, now then now, so let me execute this query. Then so now it's giving error. Okay, now this query gives what? Error. What the error is? Ambiguous department number. So it is saying department number is ambiguous. What is ambiguity means? Huh? Okay, not clear. Uncertain. Okay, na? So department number, SQL Server, confusing. Why SQL Server is confusing? Because it is there in both the tables. It is there in employee table. It is there in department table. So SQL Server is confusing that whether it should select from EMP table or department table. So that is the confusion for SQL Server. It should select this from EMP table or department table. That is the confusion for SQL Server. Okay, na? That is one problem. And another problem is you are selecting e-name. Then if you select e-name, so then SQL Server has to find out this e-name belongs to EMP table or department table. Because you are not selecting data from one table, you are selecting data from two tables. It has to go to both the tables. It has to check whether this e-name belongs to EMP or DEPT. D-name belongs to EMP or DEPT. Every field it has to check. If any field is there in both the tables, then it gives what? Error. Understood? So these are the two problems here. One is ambiguity problem. Another one, time taking. Because it has to go to both the tables. It has to check whether this field belongs to EMP or DEPT. Okay, na? To overcome these problems, one second, listen. What you have to do is, you have to write the query like this. What is that is? EMP dot. Next one, DEPT dot. Next one, DEPT dot DName. Like this. You have to write the query like this. Now you are telling Oracle, you are telling SQL Server that select the e-name from EMP table. Select the department number from department table. Select the D-name from department table. Now there is no ambiguity. Yes. Plus it doesn't need to check this e-name belongs to EMP table or department table. It doesn't need to check because we are telling SQL Server, select the e-name from EMP. Select the D-name from department table. Okay. Then now this query is working or not? Yes. But again, the problem is, so here the table name is what? Here the table name is what? EMP DEPT. Table names are short. But if you go to real time, table names may be something like this. Employee, what's that? Details. And what? Department, what? Details. The table names may be like this. If the table names are like this, you have to write the table name here. You have to write the table name here. You have to write the table name here. You have to write the table names here. You have to write the table names here. Number of times you have to write the table names. Then it is difficult for developer because the table name is what? Lengthy. You have to type number of characters. Yes or no? So to overcome this problem, what SQL Server says, give some simple and short name to the table as E, as D. What is E? Alias for EMP table. As is the E is the alias for EMP. D is the alias for department table. You are giving some simple and short name to the table. That simple and short name is called alias. So wherever you want to use EMP, instead of using EMP, you can use E. Now you can say what? E dot. Now you can say D dot. Now you can say D dot. Here also what? E dot. Here also D dot. That's that. Okay, na? Then usually can use table names, but so if table names are lengthy, it is difficult. So that's why give some simple and short name to the table. That simple and short name is called what? Alias. Now let me run the query. Okay, then one second. What is the point here? In join queries, declare what? Table alias and prefix column names with what? Table alias for two reasons. In join queries, declare the table alias and prefix column names with table alias for two reasons. One is to avoid what? Ambiguity. Another one to avoid ambiguity. Another one to another one for faster execution. You see, wait. Okay. So this is what this is. This is what then better you write query like this in all the giants from now onwards. Okay. So better to write query like this, giant queries. All the giants follow this standard. Declare the alias. Every column should be prefixed with alias. Okay. Now that's how this is what this is. So now, but this query is displaying all the employees. Okay. Then, but I want to display employee details with department details. If you ask like this, immediately should get join employee details with department details. Working at New York location. Employee details with department details working at New York location. That means I don't want all the employees data. I want to see only the employees working at what New York location. Okay. So employee details with department details working at New York location. Then what? Select what's it? Select what? E dot. You can give E dot star also. E dot star means all the fields from EMP table. D dot star. All the fields from department table. From EMP E, comma, as E, comma, DEPT, as D, where? What is the condition? E dot department number equals to. But what is this query will show? This query will show what? This query will show all the employees. This query will show what? All the employees. This query will show all the employee details. Yes. Employee details with department details. Okay, na? Next. Then, but But I don't want all. I want only the employees working at what? New York location. Okay. Then what you have to do, apply one more condition. What that is? End. Where is already there now? D dot location equals to New York. And D dot location equals to New York. Okay. Then. So that's all. Now this query will show only what? This query will show only the employees working at what? New York location. There are 3 employees working at New York location. Okay. Then. Understood now? So star means all the fields. E dot star means selecting all the fields from EMP table. D dot star means selecting all the fields from department table. Okay. Okay. Then what is this is called? What is this is called? This is called what? Join condition. What is this is called? What is this is called? What is this is called? This is called filter condition. This is called join condition. This is called filter condition. Then okay. So why this is join? Because it is joining the records of what? 2 tables. That's why it is called join condition. Then because it is selecting specific rows. That's why it is called filter condition. It is joining the records of 2 tables. That's why this is called join condition. It is selecting specific rows. That's why it is called filter condition. Understood? Then now, so let me run this then. Now this is selecting only employees working at what? New York location. Got it? Then to the join query, if you want, you can apply filter conditions also. Okay, na? No. Okay, then. See how many tables you are joining now. And one more thing, sir, we can write join queries. We can write join queries in 2 styles. One is what? Native style. Another one, ANSI style. We can write join queries in 2 styles. One is native style, one is ANSI style. Native style means SQL Server style. Okay. Native style means SQL Server styles. Next one, ANSI style. This is native style. Writing the query like this. This is called native style. This is called native style. This is all native style. One more style is there. What is that style? ANSI style. ANSI style. But okay, but nowadays, okay, na? So they use ANSI style. No one using what? Native style. But you should know. Okay, na? That's why I given the first 1 or 2 examples I given using native style. But nowadays everyone uses what? ANSI style. What is the advantage of ANSI style? Okay, native style doesn't guarantees portability, but ANSI style guarantees portability. Native style doesn't guarantees portability, but ANSI style guarantees portability. Okay, so native style doesn't guarantees portability, but ANSI style guarantees what? Portability. What is portability means? Okay, portability means, sir, if it is native style, if you write the queries in native style, if this query is migrated to other databases, okay, na? Then once again, suppose here, for example, there is a client. That client is using SQL Server, database. You return the query, join query. This is the join query, but you return the join query in what? Native style. And the client is migrating from SQL Server to MySQL. Client is migrating from what? SQL Server. Client is migrating from SQL Server to MySQL. So you migrate this query to MySQL. If this query is migrated to MySQL, it may or may not works in MySQL. Maybe you have to make some changes. Okay. But if you write the query in ANSI style, then if you migrate this query to MySQL, as it is, this query works without making any changes. That is called what? Portability. So if it is ANSI style, then portability is guaranteed, but native style, portability is not guaranteed. Okay, na? Then maybe you have to make some changes according to the database. Okay, then. So that is what the meaning of this. Native style doesn't guarantee portability, but ANSI style guarantees portability. Sir, what is the difference here? Sir, query output is same, execution is same, performance is same, whether it is native style or ANSI style. So performance is same, output is same, execution is same. Only the difference is writing the query is different. Only small change. So in native style, how you return the query? You return the query like this. In native style, you return the query like this. Yes. But here there are two changes. Your table names are separated by comma. In native style, table names are separated by comma. But in ANSI style, table names are separated by keywords. Table names are separated by keywords. That is one difference. And another difference, we don't use where clause. Instead of using where clause, we use on clause. That's all. Only two changes. What are the two changes? One, in native style, table names are separated by keywords in from clause. Table names are separated by keywords in from class. Next one. Use what on class for join conditions instead of what? Instead of where class. That's all. Only two changes. Sorry, in ANSI style, not native style. What? In ANSI style. Table names are separated by keywords in from class. Use on class for join conditions instead of what? Where class. Okay, then. So what the query? This is a query. So here we don't use comma here. Instead of comma, what? Keywords. What is the keyword we use? Inner join. Okay, na? Inner join. Next one, not what? Where class. What? On class. That's all. Only two changes. Nowadays, maximum they use what? This one all. ANSI style. Okay, now. So run this, but output wise same. You'll get the same output. Result wise same. Same output, same performance, like same execution. But only difference is what? Then writing the query. Okay, then. Next, sir, suppose I want to display employee details, employee list working at New York location. Then what? Employee list working at New York location. So I just want only ename and dname. Okay. Like location also. If you want, select location, d dot location, then what? But this gives all now. But I don't want all. I want only working at New York. Then you have to write like this. What is where d dot location equal to New York. So d dot location equals to New York. Okay, then. Okay, na? Confusion. So what are the point here? Use on class for what? And use then. So use on class for join conditions and use where class for filter conditions. So for filter conditions, use where class. For join conditions, use on class.
Okay. Okay. So let me run this then. So what this gives? This gives what only the employees working at what New York location. Okay. Then understood. That's it. So everything is same. Only writing the queries what's different. Your table names are separated by keyword, but their table names are separated by comma. Here instead of using where clause, we use what? On clause for join conditions, where clause for filter conditions. Okay, then. But in these examples, how many tables you join? 2 tables. But suppose you come across joining more than 2 tables, 3 tables, 5 tables, 10 tables, 20 tables. Then what? Joining what's it? More than 2 tables. So when number of tables increases, number of join conditions increases. When number of tables increases, number of join conditions increases. To join 2 tables, how many conditions required? 1. To join 3 tables, 2. To join 4 tables, 3. N tables, n minus 1. Okay, then. So if number of tables increases, when number of tables increases, number of join conditions also increases. When number of tables increases, number of join conditions also increases. To join n tables, n minus 1 join conditions required. To join n tables, n minus 1 join conditions required. So this is the syntax you have to follow. I'm giving the syntax in ANSI style. Okay, now then select what? Columns from table 1. Next, what? Inner join table 2 on join condition. Next, inner join table 3 on condition. Next, inner join table 4 on join condition. That's all. Like this, you can go up to 20 tables also. See which two tables you are joining. Here you are not joining table 1 and table 2 joined. Okay, na? So there should be a common field between table and table 2. Next, so that result is joined with table 3. Okay, na? Either table 1 or table 2 is joined with table 3 based on this condition. So then in table 1, table 3, there should be a common field. Otherwise, table 2, table 3, there should be a common field. Okay, na? And table 3 and this table 3 join with what? Table 4. So there should be a common field between table 3 and table 4. That's all. So we'll see the example in the next class.
Primary and foreign key when we are using multiple tables. Primary and foreign key is mostly for data integrity.
Yes.
Right. And then in this condition, when we are using not, it is mostly for displaying data.
Mm.
We want to display data. Right. So this is the difference we can say. That's right. But when I'm going to change the data type for the table, so it can't be it is converted into data. So the query the error is like which you can't change the string into the int. So then I would like to because we are in different formats. That is the reason, and then so that I like the column particular column, but it is not going to be detailed. So like all these update table names okay. I'm going to convert that usually type it once it is done, we can check it. That is also explained like that. So that is the these are criteria for students.
Sir, 1 minute, sir. Okay, sir. I will collect later, sir. Certification job. SQL Server certification exams. Course complete Madras exam SQL Server certification exams. అది ఏదైనా 2016 or 9 latest version latest version మనం డైరెక్ట్ గా రాసేసుకోవచ్చు. అది రాసుకుంటే మనకి క్లియర్ యూస్ఫుల్ అండి సార్. SQL Server yes అది రాసే one time.